So the next section is on Bitcoin and electronic voting and the problem of quantifying security in general. I'm not going to go through and describe all of the various applications of Bitcoin and the blockchain in this lecture. There's lots of other resources online that can do this very, very well. I've linked to a couple of YouTube videos and a channel that's going through essentially a 12-week class on Bitcoin. I think Bitcoin is a very interesting technology, but from a financial perspective, it is not something that I would invest in. I feel like the main problem with the Bitcoin community is they're reinventing all of the kinds of financial scams and flaws and problems that we've run into in modern finance many years ago, although now they have no regulatory infrastructure for ensuring that things like pyramid schemes don't exist and so on. You're kind of just left on your own. So let's back up just a little bit and talk about what Bitcoin and all these other cryptocurrencies are all about, because there are a lot of them: Ethereum, Ripple, Zcash, Litecoin, all this sort of stuff. They're all based on blockchain technology, which is essentially just a public verifiable ledger of transactions. So the blockchain is a way of recording transactions in a distributed group environment that is usually referred to as mining. So the mining is essentially the work required to maintain and record all of these transactions in a distributed fashion. And you get paid for your participation in the mining network with Bitcoin as a result, like the actual cash piece of the Bitcoin process. And the detailed videos here go into a lot more detail of exactly how this works and why this public ledger is so useful and so on and so forth. But from a financial perspective, as a tool for finance, I don't think it's particularly interesting because there's literally no regulatory infrastructure. There's basically no oversight, no central authority that can help manage this sort of stuff. And that doesn't mean that you can't use it for money. You can. It's just society has found that when you have something like gold, essentially an unregulated currency that you can use to pay for things, then you will see lots of scams and problems that we can do better. We can address better using even fairly basic light regulatory infrastructure. For example, theft. Like, you would not want theft to be a thing that people can get away with, and in Bitcoin they can very easily. There's basically no recourse. So you can complain about it, but good luck ever getting any compensation for it. Okay, so that's the financial piece of it. The blockchain piece of it, on the other hand, is kind of an interesting thing. This notion of a public ledger is very useful, and you can imagine a wide variety of contexts where it might be useful. One of which that is commonly suggested is electronic voting. Right. So we talked a little bit about this earlier in the semester, and I'm not going to spend all that much time on it here, other than to say that the textbook's discussion of electronic voting is actually in this chapter, and also to say that the blockchain technologies that people are really talking about are often used to justify internet-based voting. And I want to show in the next couple of slides why that is problematic, even if we had a really good implementation of electronic voting based on a blockchain. The first thing is to think about what is the goal of voting in the security context. So we have confidentiality concerns. Mostly we want to be able to cast a ballot without revealing our vote to others. We have integrity concerns because we want to make sure every ballot is counted, that they're all authorized people voting, and that this is done in a timely fashion to represent the actual choice of the public. We have availability concerns that, you have this pre-approved period that is the actual election, and you have to be able to vote when voting is allowed. So if somebody is able to do some kind of denial of service attack on, say, your voting booth, then you would be disenfranchised. You would lose your ability to vote. So this is like the security perspective on voting. There are, of course, more things you can add to this. I would refer you again to Brave New Ballot and the Doug Jones book on electronic voting and why they're particularly interesting, hairy problems from a security standpoint. I'll also just say this is a good summary, a pretty good list of criteria of what makes an election fair, and you can think about the security implications of this criteria list quite readily if you've been following the class. First, each voter's choice has to be secret. Each voter gets only one and only one vote for each of the offices. The voting system has to be tamper-proof, verifiably tamper-proof, and the election officials should have mechanisms that they can use to prevent people from tampering with votes. You want all of this to be recorded accurately and made available through the election period, and that there's an audit trail that can be used to suss out irregularities in voting or irregular patterns in voting. The main thing that I want you to think about is, and normally there's a like 5 or 10 minute activity surrounding this in class, can electronic voting systems actually help us achieve all of these criteria? If so, how? If not, why not? What are the other problems? Like, why is physical voting in some cases better than electronic voting? This is a very challenging task, and it's not one that we actually answer in a definitive fashion in class. So I know you can't get with somebody next to you and discuss this, but it's worth thinking through each of those issues. Can electronic voting help us achieve each of the things on this list? If so, how? If not, why not? Like, what are the other reasons? How do we do all of these things in a physical environment? Pre-electronic voting is another worthwhile thing to think about. And this leads into the problem of quantifying security. It's very, very difficult to definitively and quantitatively identify the level of security in a particular organization, whether it's financial transactions or electronic voting. Quantifying security is very, very, very hard. Even simple questions, right? Like, how do you predict the likelihood that a hacker will actually attack a particular network, are extremely difficult to get reasonable data on, because both the hacker and often the target have reason to hide the real data, right? To hide actual data about how often they're being attacked. Industrial surveys that try and do this sort of data collection, including things like the BSIM, are massively inconsistent. In part because we don't have a standardized way of doing this kind of reporting and categorization of these incidents. I know there are a couple of organizations out there like CERT that do have more data than others, but there's still a lot of people who are not participating in these organizations and people who would actually disagree with the definitions used for the categories in the first place. Lots of disagreements about where an attack is coming from, even sometimes for attacks that have multiple victims amongst the victims themselves. And then, of course, for any of these surveys, including the BSIM, you have to worry about selection bias. Are the people who are participating and responding to these surveys somehow privileged or different in some way from the people who are not responding to these surveys? And that is certainly true for electronic voting as well. A lot of the people who are often disenfranchised with new voting systems do not have the capability to participate in this kind of data collection effort simply because they're not connected well enough. They don't have the luxury of being able to spend time taking surveys and contacting pollsters and politicians about election security issues. So it's very, very difficult to get this sort of thing quantified cleanly. So if you're making decisions about any kind of security issue, the severity of the attacks, the cost, the damage, recovery, you can sort of think of this as like the insurer problem. If you are Allstate or State Farm or any of the big insurers, how do you assess the likelihood that a organization is going to have a major cybersecurity incident? You have to find useful data for all of this stuff, and it's really, really hard to do that with any sort of accuracy. So I think we are going to be stuck with this for at least the next 5 or 10 years. It's very, very challenging to imagine a scenario where we're able to get good, high-quality data without some sort of regulatory oversight, including investigatory powers similar to the National Transportation Review Board. Or the National Transportation Safety Board, or the FAA for airline-type incidents. Until we get something like that, this kind of data is going to be really, really hard to get with any level of trustworthy accuracy.